The screw is turning. Not quickly. It has never moved quickly. A single full rotation takes approximately 45 seconds when the press is under full load, which, at this moment, it is. The cast iron threads engage the wooden nut with a sound that is less a noise than a sensation, a low, authoritative compression that you feel in the floor before you hear it in the room. This is Street Cider Mill, Somerset. The press has been operating since 1903, not running intermittently, not restored between uses, in continuous seasonal service every autumn, without recorded interruption. For over 120 years. The screw itself is grey cast iron. It weighs approximately 240 pounds. The thread profile is a coarse square section, cut slightly oversized when new or deliberate manufacturing decision, the significance of which nobody at the time thought worth writing down. They didn't need to. They already knew. The founding engineer who specified it has been dead since 1931. The screw has not noticed. Before we continue, a brief interruption, which is more than this screw has had in the last 120 years. If you find value in documenting the things that were built to last, the decisions, the specifications, the engineering principles that made longevity possible, consider subscribing. This channel exists because someone should be paying attention to these machines before the last person who knows how to maintain them retires and takes the knowledge with them. And if you have worked on something like this, maintained a cider press, sourced thread-cutting stock for a machine whose foundry no longer exists, or simply watched a cast iron component outlive every expectation placed upon it, tell us in the comments. What was it? How long had it been running? What did it take to keep it that way? We are genuinely interested. Unlike most comment sections, this one occasionally contains useful information. Now, back to the screw. Somerset has been making cider for at least 700 years. For most of that time, the screw was made of wood. Specifically, elm or oak, or occasionally walnut. Timbers selected for close grain and resistance to splitting under sustained load. The wooden screw worked. It pressed apples. It produced cider. It also wore out, split along the thread, swelled in wet seasons, and required replacement every decade or so, depending on the particular cruelty of the Somerset autumn. From the late 1700s, foundries in Bristol, Bath, and the Somerset market towns began casting iron press screws. The transition was not instant. Conservative farmers and Somerset farmers have always regarded innovation, with the cautious suspicion it occasionally deserves, continued with wood for a generation or more after iron became available. But iron proved itself. A cast iron screw of the period weighed several hundred pounds and required a team of men and a horse-powered apple mill, working in concert to reach full pressing pressure. What it did not require was replacement. By 1903, when Street Cider Mill installed the press we are looking at, the wooden screw had become a curiosity rather than a component. Cast iron had displaced it across Somerset entirely. The foundry that supplied the press screw for this mill was located in Taunton. It is no longer there. The screw is. Here is the thing that engineers in Somerset did not formally understand in 1903, but that their grandfathers had understood empirically. For a century before them, cast iron, under repeated compressive load, gets harder. The material science term is strain hardening, or, more precisely for cast iron under cyclic compression, age strengthening. The mechanism operates at the level of the iron's microstructure. The graphite flakes that give grey cast iron its characteristic dark appearance are dispersed through a ferritic or pearlitic matrix. Under repeated pressure, the dislocation density within the matrix increases. Each season of pressing loads the thread surfaces. Each load cycle rearranges the crystal lattice microscopically. Each rearrangement makes the next load slightly easier to resist. The effect is gradual and cumulative. After 20 years of pressing season, the thread contact surfaces of a well-used cast iron screw are measurably harder than they were when cast. After 50 years, the differential is substantial. After 120 years, the thread surfaces of this screw, in the specific region where they bear against the wooden nut, are among the hardest parts of the original casting. The Victorian foundry men knew this not as metallurgical theory, but as observed practice. They had watched cast iron screws last longer than anyone expected. They specified thicker thread sections than strictly necessary and cut them oversized. They knew, without equations, that use was the best form of maintenance. The design specification called for a 20-year service life. The engineers who wrote that down either lacked confidence in their own work, or more likely wrote a conservative figure, because that is what engineers who have seen enough poorly made things tend to do. The genius of this press, and it is a form of genius, even if it was unremarkable to the people who built it, is the deliberate separation of the permanent from the consumable. The cast iron screw, permanent. The wooden nut through which it turns, consumable. Replaced when required, machined from elm or fruitwood, costing very little and lasting perhaps a decade before a new one is made. The pressing boards, the elm slats that separate each layer of pomace. Consumable, replaceable, available from any decent timber merchant. The horsehair pressing cloths, consumable, acquired as standard agricultural supply, cleaned and restacked between each use. The iron, permanent. This is not an accident. A Victorian foundry engineer in the Somerset tradition understood something that modern industrial designers have systematically unlearned. The correct strategy for a machine expected to operate for decades is to make the expensive parts permanent and the cheap parts easy to replace, not to make everything equally durable, not to make everything equally disposable, to deliberately differentiate. The thread nut on this press has been replaced 11 times. The pressing boards are renewed each decade. The cloths are cleaned each season. The screw has been refinished once in 1954, when a hairline crack was identified in the upper shank, and welded by a blacksmith in Street, whose workshop address is still recorded in the mill's maintenance ledger. One refinishing, one repair, 120 years. The modern hydraulic press that a neighboring mill installed in 1989 was replaced in its entirety in 2014. The manufacturer no longer offers service contracts for that model. The cast iron screw does not have a service contract. It doesn't need one. In 1983, a regional agricultural development officer visited Street Cider Mill and wrote a report. The report noted that the press was, in his words, of antique design and not commercially competitive with modern hydraulic alternatives. It recommended replacement as part of a modernization grant scheme. The replacement unit specified in the report was a German-manufactured hydraulic press with a stainless steel ram and an electric motor. Delivery was quoted at 12 weeks. The grant would have covered 60% of the purchase price. The miller at the time read the report, filed it, and continued pressing. He had been maintaining the press for 19 years at that point. He knew the screw. He knew its sounds, its rhythms, the particular resistance it offered in the first hour of pressing, when the cheese had not yet consolidated, and the steady authority it assumed once the pomace was properly compressed. He also knew something the development officer did not, that the wooden nut would need replacing the following year, at a cost of approximately 40 pounds of timber and one afternoon's work from a local carpenter. He calculated the comparison himself, on a sheet of paper that is still in the mill records. The German hydraulic press cost more to service in its first 3 years than the cast iron press had cost to maintain in the previous 3 decades. He did not replace it. The development officer's report has not been acted upon. That was 43 years ago. The man who maintains the press today learned it from his father. His father learned it from the miller, who had operated the press from 1947 to 1978. That miller had learned it from the man who had installed it, who died in 1941, having never used a hydraulic press, and apparently not feeling the lack. 4 people, 120 years. No manual. There has never been a written maintenance guide for this press. What exists in the mill records are the dated entries: nut replacement, cloth renewal, the 1954 repair, but nothing that tells a new engineer where to look first, how to read the sound of the screw under load, when a change in rotation resistance signals a nut reaching end of life, rather than a change in pomace consistency. That knowledge is passed through the hands. A hand placed on the press frame during operation tells an experienced maintainer things that no vibration sensor yet devised can accurately convey. The warmth of the cast iron under sustained load, the minute variation in resistance, as the thread engages at different points in its rotation, the precise moment when full pressure has been reached, and the press will give no more. The current custodian is 61 years old. He is aware of this. Last autumn, for the first time, he invited his daughter to join him for the pressing season. She is studying agriculture at the Royal Agricultural University in Cirencester. She had not previously been interested in the press. She is now. The screw is still turning. It will turn again this autumn, and the autumn after that. The wooden nut will be replaced in 3 or 4 years. The current one is showing the first faint signs of thread easing that indicate it is entering its final seasons. A length of elm has already been sourced from a timber yard in Shepton Mallet. The carpenter who will machine it has been told to expect the call. The pressing cloths were cleaned last November and are stacked in the order they were last used. The cast iron screw has required no attention. This is what it looks like when a machine is designed correctly. Not a machine that never needs maintenance, but one whose maintenance is so well thought through that it becomes a routine rather than a crisis. The screw gets stronger with each season. The wooden components wear as they were always meant to. The knowledge of how to manage the transition between the two is held, at this moment, by a 61-year-old man in Somerset, and, since last autumn, also by his daughter. That is not a comfortable margin, but it is enough. For now, if this subject interests you, and we suspect it does, since you are still here, subscribe to the channel. There are more machines, more systems, more decisions made by engineers decades ago that are still paying off today, largely unnoticed by everyone except the people keeping them running. And if you have a connection to what we have just described, a cider press you have serviced, a cast iron component you have watched outlive every replacement schedule written for it, or simply the knowledge of what a well-designed machine sounds like when it is working correctly, tell us in the comments. The engineering knowledge that kept these machines alive was never written down in a form anyone thought to preserve. It lives in the people who learned it from the people who built it. We would like to hear from them before they stop answering questions. The press at Street Cider Mill is still turning. It will require maintenance next autumn. The same maintenance it has required every autumn since Edwardian Somerset. The parts are available. The knowledge exists. The will to continue is present. None of this is remarkable. It is simply what happens when something is built correctly. The remarkable thing is how rarely we do it.